By carrying out appropriate calculations, determine whether Jan's plan is likely to work and describe what resonance might occur in the pipe. You may include a sketch as part of your answer. Okay, so excuse me, what we have to compare here is the wavelength of middle C in carbon dioxide. So our blue can be our carbon dioxide medium, CO2, compared to, let's do it with red, the wavelength of C in the wavelengths available in the pipe. I'll just call it pipe. So we want to see whether it's possible to fit a carbon dioxide wavelength into the pipe for there. So first of all, let's do the wavelength of middle C in carbon dioxide. So the frequency never changes. Remember, from all of your level 2 stuff, you deal with waves and light, water and sound waves. The frequency never changes no matter what the medium or the depth of water. So the frequency stays the same. The velocity changes, the wavelength changes. So we've got a new velocity, which was, let's see, 259 meters per second. Our frequency is still the same, 261.1 Hertz for middle C. And we're going to work out our wavelength. So just a V equals F lambda will give our wavelength of middle C in carbon dioxide as equal to 0.992 meters. So that's quite a bit different from the 1.31 meters that we found earlier in air. So now we've got to look at the wavelengths that can be supported by this pipe. And just going straight to it rather than the mucking around, you would have to try all of the different frequencies which could fit in. The closest one that would fit in, which is over the top of C, is you'd have 5 quarters of the wavelength equaling L. That is, you'd have an antinode here, a node here, and you would need excuse me, another node, another antinode, another node, and another antinode. I've squished this up a little bit, but so let's node, antinode, node. Okay, so you get the idea, even though it's not exactly to scale, because you can see that that part should be the same length as that, and that should be half of both of those. But anyway, and so if you were to calculate the wavelength from this, because L is 1.31 meters, so you just rearrange this for lambda. Excuse me, lambda would be 1.048 meters for SF. Since we're looking, we should really have that to 3SF, but we're going to use it in a subsequent calculation. So that tells us our 1.31 meters will, hang on a minute, we might have to go over the top of that. Okay, yeah, got it clear I think now. So that wavelength that we just calculated is the wavelength that will fit into this pipe under this 5th overtone, and this is the wavelength over here that C is in that carbon dioxide medium. So you would definitely be able to fit 0.992 meters into 1.048 meters. Because there's a speed difference though, to get it exactly the same, you would have to have a little bit of air mixed in with the carbon dioxide to bring the speed up a little bit more. So what speed would you exactly need? If we were looking at this 1.048 meters at a frequency of 261.1 Hertz for middle C, the speed that you're looking for would be, just using V equals F lambda again, the speed you're looking for would be 274 meters per second, which is faster, definitely faster than the 259 meters per second from the pure carbon dioxide. So if you mixed in a bit of air, that would bring the speed up, and that would cover it, I guess. So the plan could work. That's the idea. Just determine whether Jan's plan is likely to work. It's really important to answer the question. So you would then make a statement, something like, yes, it is likely to work, but with, moving down, with CO2 plus air to get the speed right. There. And this, I think, is quite a hard question. This would be a scholarship level question based on past papers I've looked at, to be able to hold all those bits in your mind and think through it. But so what you're going to find, just as an interesting little note, is that questions in the new level 3 focus and the level 2, the way NCEA seems to have gone is that they have one really, really hard question in each paper to help provide distinctions, to actually give the top, and then those who are doing not quite that level, and just helps to have a finer dividing up of all the student answers. But anyway, that's that. There you go.